Well, hi, good morning. Thank you for joining me here. Today is July 23rd. Looks like another just beautiful day outside, and I believe a heat wave is coming. In fact, I think a gigantic heat wave is coming, mostly in the States, in the central states, like a scary heat wave. And I'm sure we'll feel it up here too. But I don't think it's going to be quite as hot as south of us here. Wow. Okay. So I think the best thing I can do is do a quick recap, even to just clarify in my own head where I'm at. But basically, I'm in about the worst situation you can be in with a radio like this. And what I mean by that is, the radio was largely not working. I made a change. The radio is still largely not working even worse, it appears. I'm not absolutely sure of that, but so that puts me in a position where, gee, is the problem because of what I did? Or is the problem some other thing in the radio? And I continue to focus on what I did. I'll never solve whatever the problem is. It's somewhere else. I have to go somewhere else to find it. The problem expressing itself as a hum in the radio and a lack of performance. And even insensitivity to band change and touching the antenna and stuff like that. If you can hear some noise in the background, that's my cats wrestling and fighting in other parts of the house. Well, and that's exactly what I know to do. I don't know what to do. I really don't know how to approach this now. So I guess the first and most realistic possibility is I still don't have this transformer in correctly. I don't think the transformer itself can be the problem. Like I've taken out one kind and put in another kind. No, they're almost identical, I'm sure. And so I don't think putting in the new transformer is in itself a problem. Getting it done correctly is the problem. Wiring in here has gotten pretty messy because I've had to put extensions in to reach terminals and that. I think probably my time best spent is convincing myself that this is installed correctly. And if I can convince myself of that, which I'm kind of convinced right now, but I think I need a real good convincing here, then this stops being an issue in terms of the operation of the radio. In terms of an error. It's still an issue, it's not tuned. I haven't tuned it yet. Even that could be part of the picture, perhaps. If I tuned it properly, maybe the hum would go away. Well, why would the hum go away? Yeah, so I think that's the first thing. Absolutely convince myself I've got this in here correctly. Okay, I know what I have to do. Okay, I finished examining the situation. Here it is. This is the transformer here. These are all the leads showing where they're going in the circuits. And I've compared this to the schematic. It absolutely matches, except I have reversed these two connections. I did that after putting them in what we might call the normal way, and then I decided I would reverse them on the basis that I had a concern that we're flipping the phase of the actual signal we're trying to listen to on the speaker. We're flipping it here by accident, and so by rewiring this I would unflip it, and somehow that would be beneficial. I'm not even sure it would be. I don't know if it matters at all. But there is one interesting aspect, and that is this is the transformer I've been working on. This is the other transformer, just this little piece here. And you can see there's a connection between pin 4 or terminal 4 of this transformer, and it should be to 4 of this transformer. But because I've reversed these, it's now going to 3, along with everything else going to 3. That's a curious connection, come to think of it. Well, why would you have a resistor doing that? So this is B plus coming in here. We'll look at this on the schematic and just because it's really not making a lot of sense to me. I'm sure it's true, but let's take a look. Okay, so here's the two transformers here. You just gotta put it like that. Okay, this is the second one. This is the one I replaced here. This is the second one. You look at terminal number 4 and follow this wire. B plus, 1000 ohms to here. Oh, it's 1,000. So the B plus is coming this way. They're shoving it through 1,000 ohms. Now sometimes these 1,000 ohm resistors sometimes are in there to allow for measurements. They're not actually affecting the operation of the radio. It's just 1,000 is a nice round number, and if you read the voltage dropping across it, you can get an idea of the current through it. So there's another 1K over here. Now, I'm not saying that's the case, but that's a pretty small resistor in the midst of a complex B plus system here, because the B plus is also used to drive the tube heaters. And in this kind of radio, you know what? They might want to enable this kind of measurement right at these two locations. How much of the B plus current is flowing here, and then how much is left here? I don't know. So, but the fact is, this resistor is tied just as you see it. You think if this was about measuring current, they would put some information right here that would help you in that measurement. Like they'd write the amount of current flowing right here, but they didn't. Okay, so the bottom line is I've got this installed just as you see it here, except 3 and 4 are reversed. Can't imagine why that would generate a hum or even bad performance. And even though I talk about the 180 degree out of phase thing, I don't even understand why that would be a problem. Why would that really be a problem? So, where are we with this then? Where am I? What am I doing? Why am I here? Okay, I gotta stop and think for a little bit. Okay, having a moment with my cat here. So, I can only conclude then that whatever's not working right in this radio in terms of the hum is not coming from down here. It's not coming from this from the transformer I installed. Good conclusion. It's not doing me much good. You know, it could be hum coming right from the power supply, and somehow I convinced myself incorrectly earlier that there was no hum, because I did. So I could go ahead and I could augment these. Yeah. I wouldn't even have to replace them right now. I could just put in a little extra capacitance. The thing is the rectifier, this blue thing up here, might be overstressed on startup if I put more capacitors in here. Plus, this is all involved in the heater string and the heater string. Well, there's something I can take a look at there and get some more information, and a suggestion that came to me via email, which I think is a good suggestion too. This particular radio has a very peculiar way of powering all the tubes. They're all in series, and there's resistors and all kinds of stuff going on to try to make that work properly. If anything is out of sorts, then we could get an imbalance in the voltages in the heaters, maybe one heater running with too much voltage and another one without enough, something like that. The information's available on the schematic. It shows from tube to tube to tube. So since I don't know what else to do, let's do that, and we'll just measure the voltages and compare them to what it shows on the schematic. Good idea? What do you say, Bert? Look at this guy, just takes control of my keyboard all the time. Yes. Calm me down, cat, because nothing else does, it seems. Yeah, I'm referring to, watching the news and stuff like that. Ooh, I have lots I could say, but who needs to hear it? If you notice, I haven't done any of those stand-up videos, and the reason is that, well, what have I got to say that's going to enlighten anybody? I'm trying to keep myself enlightened. Well, you can probably hear my air conditioner running. So the way this works is one end of the heater string is grounded to the B minus, not to the chassis, but to B minus. And let's see how they're showing the voltages here. So they're showing, if you measured from here, I believe, from here across on this tube, you get 1.4 volts. I think the nominal heater voltage is 1.5, I think. So we just would work our way up the circuit, which is easier said than done because it looks nice on the diagram here, but working your way through one tube after another is going to take a bit of time. And this voltage is measured, yeah, it's just slowly going up. 6.4 and then finally 9 at the top. So really this is an important voltage to measure right here, 9 volts right here, which would verify most of this stuff back here. If we have 9 volts here, but it also depends on the heater string and everything. Everything depends on everything. This is a very precarious way to build a radio. Any little trouble anywhere in here and the whole thing goes crappy. So this is probably the best place to start. So I'll set up a voltmeter. It says use a VTVM. Let's see what's going on with the power supply here. The plug is coming in on this side, and then just working its way through all this stuff, rectifier and the rest. Then the other end must be tying to one of these. Must be tying to B minus. Oh my God, I'm not going to be able to sort this out, but I'm pretty sure that's what's going on. Yikes. So let's see, so this switch, and this one, they're all connected together, and this one too. And this is probably the switch that's operated when you shove the plug into the battery spot. There's a spot where you're supposed to park these plugs inside the radio. When you do, you operate these switches here. And it switches the whole thing over to battery operation. Well, I don't see it completely clearly, but I think this other leg has to go to the B minus. It's got to be attached over here. So we have the whole AC from here right across this whole shebang. Of course, it's not AC after this. Okay, I think I've looked at this enough. I think I know what I'm doing. That's dangerous. Let's find. This point's easy to find because the rectifier's right here. That's easy to find. It doesn't give me the voltage though, does it? 92 volts, 95 volts. Yeah. Just looking for voltage indications here. They didn't really do it up there, did they? Just here. Okay, that's enough looking. Okay, so looking at this a little closer, and you might have some trouble seeing this on your screen now because it's a little small, but here's the main rectifier, and right after it is a big filter capacitor. And then over here we see 9 volts. And if you come back, it's just a wire until you get to this big resistor. Look at this thing. 2000 ohms, 10 watts. 10 watt resistor. And I think I know where that is. So on one side of this 10 watt resistor is going to be 9 volts. The other side would have 90 volts on it, I think. Something like that, 95 volts. And I trace this all the way up here. It even says, well, 90 volt battery. So somewhere in the range of 90 volts. Okay, so that resistor, really, either side of this resistor tells the story relative to B minus. Okay, now that resistor, are there not diagrams? Were there diagrams in this manual showing the parts locations? Oops, not down here. Up, 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 up. I thought there was some parts. Here we are. So I think it's this great big resistor sitting right here. This thing, R23. Okay, back to the schematic. I should have noticed the number earlier, but I didn't. So this big fat resistor here is R23. Okay, sorry, you may not have seen that because I didn't put it full screen. Sorry for that, but nevertheless, this is definitely the resistor. This is definitely the resistor right here. Whoop, right where? Right there. This great big thing here. So one side. So here's the side with the capacitor, and here's the other side with the switch. So we look at one side with the switch, and the other side with this capacitor. Perfect. So the side with the capacitor is 9 volts. I think I got it. I think I know what I'm doing. Really? Do you? Okay, so I'm going to want to clip this with a clip lead to B minus, so I don't have to worry about it. And you know, so I was going to use my VTVM, but I got a little nervous about attaching a ground inside the circuit here, so I'm using a isolated meter. Just back this up just a wee bit. Okay. So a good B minus point would be, could be right in here. Okay, and now I'm going to practice. Easy to practice. Here and here. This side's got 90. This side's got 9. That's the theory. Ooh, what's it showing there? Some numbers came up. Okay. Volume down. I'm going to want the supply to be fairly accurate too. Everything's okay otherwise. Any cat eye? Nope. Okay, here we go. Okay, with the dim bulbs in. We are coming up 104 volts here. Okay, so it's behaving the way, at least it's behaving consistently. 60 volt scale. Let's go up to the 600 volt scale. 90 volts, please. Okay, how about over here? Okay, the 98 volts there. Okay, that sounds okay. But on the other side, 6? No, that's supposed to be 9. Oh, 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 oh. So I'm going to raise the voltage up to, what did they say? They actually have it written here in a table. The radio is being fed with 117 volts. So I'm going to raise this up to 117 here. Ooh, ooh, ooh. Slow down there. Okay, 117. Is that going to make a difference? Yay. Made a difference there. 7.5. Way low still. Oh my gosh. Well, it could be low because this has gone high, and a myriad of other reasons. You know, these are not friendly radios to work on. I've had a number of these across my bench over the years, and every one of them I've kind of gotten bent out of shape on it. the one I own, I own one exactly like this, and it works. Thank God. Because how could that help? I brought another radio in here exactly like this that works. Put it here. Check voltages. Is that really worth doing? That's a lot of work to get there. I can check voltages against a schematic. Why do I need another radio that may have its own problems? Even though it works. Well, I should turn this on because having it on for no good reason. Well, the obvious thing is the potential that the resistance of this big resistor is off. Now it looks like a wire wound resistor, so it's really not very likely. I think it's a 2000 ohm resistor. Was it 10 watt? Here we are. 2000 ohm 10 watt resistor. Did it get warm? Oh yeah, got warm. Okay, well, how many ohms are you? So making a measurement of a resistor in a circuit, the reading is either the value of the resistor or the resistor is higher than what you're reading because of alternate current paths, giving the meter the impression there's a lower resistance. So instead of 2K, it's 2500 anyway. See, it's cooling down, I think. Is that why? Is it dropping? Looks like it's dropping, doesn't it? I think it's because it's cooling off. Well, that's an interesting question. Then it's got two ratings. One when it's cold, one when it's hot. 2000. 10 watt resistor. Oh my gosh, have I got a 10 watt resistor? Oh boy. And another thing you could do is parallel it. Put in a parallel resistor to adjust the total resistance, and the parallel resistor wouldn't have to be a 10 watter. That's probably a better way to go. Well, what's that got to do with the hum in the set? It probably has nothing to do with the hum. If we look at the circuit here, let me put it full screen just for a sec. Okay. And we're going to zoom in a bit. So look at all the components that go to ground here. So we've got electrolytic capacitor here, 100. This one I changed. We've got this 80 that's part of the main capacitor, the sectional capacitor. We've got this capacitor going to ground. We have this takeoff here. What is this? V2. 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 Detector. Well, I don't know what it is. it's something. We also have this block of parts. There's two of them in this radio. There's one here and there's one here. And these parts are all contained in a package, and they can fail. And you can't go in and replace this inside the package. So in the worst case, you have to remake this with external components. In some cases, the component that gives trouble in here is actually, you can actually just tie something to the leads outside of it and compensate. But this could be a problem. The hum, it's a hum. So a hum can only come from unfiltered AC. Well, not quite true. You can pick a hum up out of the air too. But chances are, if a radio is humming, it's because the power supply is not filtering the AC properly. And that would lead us back into these guys. I could put my scope on the power supply here, and we can look at it, and on a percentage basis we can figure out how much ripple there is in the power supply. In fact, we could do that down here and just see what's going on, and maybe we'll see there's a big ripple. And there's if you have a ripple in here, you're going to hear it, because it's going to be it's going to affect the operation of every one of the tubes here. That's an idea. So we'll put the scope on, maybe right here. Once again, it just has to be on the other side of this guy, and we'll look at the voltage and try to assess the percentage of the hum. At this point, see a 3V4. I think this is the output tube, and I'm not so concerned about hum at this point, because you need like the amplification factor and the hum level on that is such that a little bit of hum you can't hear it. Back here is not the case though. Back here, a little bit of hum and it's going to show up. And this hum sounds like intermodulation hum to me. It doesn't sound like audio hum. It sounds like it's happening back here, which would really mean right here is really where I want to put the scope and take a look. Well, let's put the scope and take a look. Okay, I think we're ready for this test. Now, the scope's hooked up to nothing, and we're going to be hooking it up to the filter capacitors right here. So we're going to be doing that. Just doing that. Okay, I'm going to switch on the radio. So we got this set way too sensitive here. Here we are. I'm going to speed this up a bit. No, slow it down a bit. Oh, look at that. Look at that. Okay, so what I'm going to do, I will remove the voltage. Now, set the zero line properly right in the center here. Pretty much in the center. There we go. And I'll put it back on. We're on 5 volts per division, so that's roughly 10 volts. Look at the size of the hum. That's with a new capacitor there, isn't it? No, I'm not. You know where I am? I'm not in the right spot. I'm on the resistor. I'm on the filter side of the resistor. And it looks like that. Let's go further up in where I really intended to do this. And that is on this capacitor that's right in the middle of the string. Oh, I didn't see anything happen there. Tiny little voltage. Okay, so we'll put this on 1 volt per division now, and I think I've got the I got the times 10 going here. Let me flip it to times 1 for this. Oh, well, let's go back to this guy. Can't even get it on the screen with the times 1. Okay, with the times 10. Now we're looking at 50 volts per division. So this is more like 100 and something with a hum on top. Ooh, wow, that's quite a difference. And that is supposed to be the 90 volt one, isn't it? Yeah. And then this would be the, this is the other side. This is the, what am I talking about? I don't know. Just stop talking. Move some knobs around and stuff. Okay, so back, 0 is there. Okay, we are now measuring on the 1/2 volt per division. Not even a volt. What am I doing? complete control of what I'm doing here. Okay, let's get off that and go where I really want it to be on this capacitor. Okay, and I'm going to take a peek at the schematic here because I think it tells me what voltage should be there. So on that capacitor, that's the 100 that I put in. Yeah, I can see 100 on it. Should be 6.4 volts relative to the B minus. 6.4 volts. Well, I don't think we're anywhere near there because it's hold on, times 10 is going. Times 10 is going. Hear the radio ring? Okay, that's interesting. Don't know what it means. So we're on the times 10. Get it right, Jim. Let's put this on the 1 volt, because then I can't make a mistake. So we got half a volt times 10, 5 volts. 0, 5 volts. And we're supposed to have 6.4. It's low again. As for the hum level, so I'm going to make this much more sensitive here. I'm going to flip this to AC and then make this much more sensitive. So 1 volt will go to 0.1 volt. You can see a little bit. Is that okay? I don't know. So now we're at 10 millivolts per division. So what's that? That's roughly, say 10 millivolts there. And the actual voltage on that 1 volt is half a volt. So what was that again? Half a volt and 10 millivolts. Well, it's hard to see how you can make that any better. I put the new capacitor right in there, unless what's happening is this circuit is being presented with a whopper hum from the power supply. And when we looked at the power supply, we saw pretty distinct the filtering appeared a little short. Let's look at all the different capacitors here. Put this up. Put this on 1 volt per division. Did I just bump something? Where to go? Wow. Okay. And still on the times 10. So it's 10 volts per division now. 10 volts per division. And what did I say we're going to do? Look at the tops of this capacitor here. I just want to make sure I'm not going to get a shock. So this is the same, this is the resistor thing. Look at that. Now I've got the scope sent to AC, so the DC component's not showing up. We're just seeing the AC component. That looks terrible. Look at this one. So you saw the DC charge push the line down until the charge evened out inside the scope, and then look at, we've got nothing here. Nothing. What about over here? A tiny, I can see a tiny amount of hum there. Okay, and then what about here? What did I set this back to 1? You see nothing here. So really, if we leave it set like this, the scope, and I just go around to the different pins, look at this thing. Whoa! There's a bit of a hum there. There's a quite a hum there. Quite the hum there. Oh, I've seen enough. I think I may misassess this at the very start. At the very start, I listened to this radio and I thought, yeah, no hum.
10:19 a.m.
Oh, jeez, my watch just scared the living daylights out of me. Who's in here with me? Whoa, that was scary. Yeah, my watch, for some reason, I bump it or something and it announces the time. I have no idea why. Turn the power off, Jim. You're getting too excited here. I'm gonna make a mistake. Okay, I think the name of the game is drive the hum out of here. Augment this capacitor with more capacitance. If we look at the schematic, let's take a look at the schematic for a moment here. My concern here is if we like, you know, this is already 80. You know, for me to bump this up, I got to add another 50 anyway to bump it up significantly. So let's say I drop a 50 here now. So now together it could be 130. Big empty bucket here. Big empty bucket. Turn on the radio, and right away you try to fill this empty bucket. And while it's being filled, a heavy current flows through here. Now it might only take, I don't know, it might only take 10 cycles. It might take a second. I don't know how long it takes to charge this. There's no resistor in here. There's one back here, a 2 water. So sometimes a capacitor, resistor will be installed in a circuit in the power supply to simply limit the rush current. In a tube radio, the rectifier heats up and kind of comes on slowly, if you like, or it takes a few seconds from start to finish of it delivering voltage. Whereas with this, the moment you turn the radio on, this thing is delivering voltage here. So the whole thing is there, empty bucket. Make this bucket too big, burn this guy out. Now the other thing is, this is a kind of diode which is considered to be unreliable and has the potential to fill your house with acrid smoke if it lets go. So I've heard. I've never seen it. Is this one hot at all? The set's not on. I can touch it. It is warm. It's definitely warm. These guys do get warm, and they do drop some voltage. If you replace this with a more modern, simpler diode, you can get too much voltage over here, which wouldn't make a lot. Hey, you know what? There could be an advantage to this actually. It wouldn't make a lot of difference in most radios, but in this one, if you jack this voltage point up a bit, you jack up the current through all these tubes, and that may not be a good thing. Now, we aren't talking about a huge difference here. So what a lot of people will do is they're going to change the old rectifier with a new silicon one. They'll put a voltage dropping resistor in. Considering I've measured the voltage low over here, maybe changing this to a regular diode now might result in an increase in the voltage, but it wouldn't be for good reasons. We still have this guy measuring at 2500 when he's hot. 2000, 2500, that's enough. That's enough to knock these voltages down to the range they're at. How big a deal is it anyway? So what if there's a little less current going through here? All these tubes run a little cooler. Don't deliver as much current. Last longer. The other thing too, there could be imbalances in here, and one of these tubes may be getting a little more than what it really deserves, but with the reduced voltage, that's okay. He's not overstressed, even though he's carrying too much load. That's a bad way of putting it. I shouldn't use the word load, but you know, because it could be, well, what is there in here? Is there a resistor right in series? Well, all these are parallel. Wow. Look at this. They're all paralleled with a resistor. That could be why if you pull out one of these tubes, you pull out this element, but you leave this resistor in place. How would that burn out the rest of these? I don't know how that would happen, but it's dangerous to pull a tube out of this radio with it operating, or to operate it with one tube short, one tube missing. Don't quite see why, but I'm not here to find out. Had that experience once already. Okay, I got a list of things now. Probably the first one is augment the power supply capacitor, and then deal with this resistor. And in the meantime, I got to scare up 10 watt 2K resistor. Oh, you know what? I got lots of 5 watt. I can do it. I got 10. I got a crying out loud. I got a 20 watt resistor right in my hand here. And how much is it supposed to be? It's supposed to be. I'm looking at the wrong one. 2000. Yeah. Well, I'll have to hunt through my resistors. I may have one. Okay, enough babbling here. So I think I'm gonna call it quits here. Tomorrow I'll carry on with these two ideas, and especially the augmentation of the power supply filter, which is usually step number one in most of these radios. And maybe I should have done that right off the bat. But like I say, I got myself convinced there was no hum. Well, I'm convinced otherwise now. Okay, well, thanks a lot for watching. It's a beautiful day outside. A heat wave is coming, apparently. Look out if you're American and you live in the central United States. Look out. Really hot weather is coming. So thanks a lot for watching, and see you tomorrow.